Okay, so how basically does it all works? So on the picture, for example, you can see this is one of our laser units, this is the key component, I would say, for the fiber optics monitoring systems in general. So let's break it down to a few steps here and go through each and every step to kind of understand it in more details. So the system analyzes the structural health of basically any type of infrastructure around the clock. So it sends the signals almost every second. So this is the way we receive data, and then we process and analyzing it. So collection data on a state-of-art infrastructure and transfer and stored on a secure server. This is what we do in the step number 2. In case of some kind of event acquired, the system will send an automatic notification to the designated personnel, notifying about the place and also about the type of problem which is acquired at that location. So we can know precisely where, at what point of time, and what sort of damage based on the data received is acquired. And then the last step would be basically giving the instructions to the responsible personnel to take timely actions and go and investigate further that problematic location and see what measures needs to be taken in order to fix those issues. All right, so let's jump to the next slide. Yeah, so basically, let's talk about what kind of results can be achieved using the MSGecko system. So basically, with this system, there are a few key points that we can achieve. First of all, we can the entire infrastructure with the smart sensors, which will transmit the data 24/7 around the clock with non-stop, so we can receive a huge amount of data that can be later analyzed and some kind of damaged and location, like problematic locations, can be discovered almost in a real time. Then we can carry out the necessary maintenance works. This help us to avoid, the entire system shutdowns and optimize our expenditures, help us to save the cost, extend the service life, and maximize the return on the investment, and then ensure the safety and security of the users and personnel who are using that infrastructure at the moment. All right, let's jump to the next slide. Yes, so now let's talk about the different parameters that we can monitor. And this is just one short list of those parameters. Those parameters can be expanded by adding different type of sensors which are required by the project. But just to give you an example, so with the help of the fiber optic monitoring technology, we can monitor the settlement, even the corrosion level, unusual structure deformations, joint movement, localization of water ingress points, unusual temperature, panel liner collapse. So this is the point I think is very important, because these basically address the entire tunnel structure, and we can see how the ground pressure is affecting the structure of the tunnel almost in real time, and then vibration monitoring, damage detection, etc. also the strain monitoring. So this is also correlated to the deformation of the structure of the tunnel networks and also the railway itself. Okay, let's jump to the next slide. Yes, so this is something we already talked about. So crack monitoring, this is very important so that we see and we can prognose which cracks needs to be classified as, that require immediate actions, or some damages that might not require immediate actions, but something that can be put in the next maintenance schedule. Continue ground movement and displacement. This is also very important, and we can do this monitoring over a long distance. And then continuous temperature monitoring as well, because across the entire infrastructure, so that in the case of any potential threat of fire within the tunnel, we can pretty much detect it within a 1 meter accuracy, and then we can take the immediate actions of further prevention, and we can basically monitor any kind of unusual temperature spikes across the entire infrastructure. So this is very precise method of finding those spots which require immediate actions. All right, let's jump to the next slide. Okay, so let's talk a little bit more about the technology. Yes. So as a let's say at its core, we use the fiber optic distributed technology, which combines basically, let's say, it basically can allow us to replace thousands of point-based sensors with the single line. So this is something unique, and it has a very good and rapid growth over the past years. The technology itself is very sensitive, very accurate, and also it's adaptable to almost any environment. Another advantages of this technology would be that it's completely passive. It does not require any electricity, and it can be used in any hazard environment or environment which is sensitive to any kind of electricity, and places where there is a high chance of explosion or fire in case of some, electricity charges or some kind of events that may cause some explosion fires. So this is the perfect technology for those type of projects as well. All right, let's move on to the next slide. Yes. So basically, placing the sensors along, let's say, the railway, the tunnel networks, we ultimately receiving thousands of monitoring points, which we can program in a certain way to receive valuable data on the strain, on the temperature changes, and we can cover tens of kilometers with just a single unit. So this makes it basically an unbeatable technology compared to any other traditional sensors that are out there, based on the either it's a MEMS technology, which is you can interpreted as a microelectrical mechanical systems, which are point-based sensors which require electricity, and they can only work at a certain locations. With the fiber optics, you have the ability to cover long distance and place tens of thousands of sensors across this entire length and have a very high accuracy at the same time. All right, let's move to the next slide. Yeah, so this is a little bit about the cable. So on the picture, you can see the construction of the cable. This is just one example. Obviously, depending on which parameters we can monitor, we use different type of cables. But at its core, this is you can see how the sensing cable is and the layers it's made of. Okay, so let's move to the next slide. Okay. So basically, the way the principle of work is pretty simple. We have a certain cables across the infrastructure that we place, and then we use the laser unit to send the laser beam inside of the cable. So this is just a beam of light which travels at a super high speed, and then it returns back to the original unit. And then this is how we receive the data. So there is thousands of data received every second, and then any changes within the when the light is traveled inside the fiber optic cable is transmitted back to the central unit, and then it gets analyzed by our software. And then the software will see what is happening at those different points, and then it will come out with some sort of results, which will tell you where you have what kind of issues based on the cable behavior at a certain point. Okay, so let's move on to the next slide. Yes, we're going to talk about I already covered a little bit, but we can cover more about the advantages of the fiber optics compared to the conventional monitoring technologies that are out there. Okay, let's move to the next slide. Okay, so yeah, just a few advantages. First of all, it's simple installation. Like if you need to install, let's say, 1,000 sensors across any infrastructure, and those are point-based sensors, you have to spend a lot of time on installation and configuration of those sensors. While with the cable, it's much more simple and much faster installation. It's also the size. The cable is very compact, lightweight, very easy to carry, very easy to install. The service life of the cable is much longer than any of the traditional sensors. So we count it as 30 plus years, the service lifetime. Again, it's completely immune to electromagnetic interference and any kind of electrical hazards. It's immune to radio frequency interferences. It's immune to basically any other hazard environment that you can imagine. It also does not afraid of dust, dirt, water, or anything else. It does not affect the signal, and the data can be received pretty accurately. All right, let's move to the next slide. Yeah, so this is also there are a few more points that we can cover. So first of all, it's the dynamic measurements. So as I mentioned, that light is traveled at extremely high speed, which consistently brings data to the central unit, and then this data gets analyzed. Also, multiplexing is one of the key advantages. So if, let's say, if we have one infrastructure and then we want to expand further, we just add, either we add more cable, or we can build, we can add more units plus cables to increase the coverage of the sensing technology. And this is done much easier compared to any other like a conventional technologies that are out there, in case you want to expand the coverage of the system. Also, high performance, high accuracy, and long coverage. This is something that can be achieved with the fiber optics, and the possibility to measure the multiple parameters within the same cable. So with the conventional sensors, you have one sensor which is responsible basically for one particular task. And so if you want to measure multiple parameters at the same point, you have to install multiple sensors. While with the fiber optics, you can get data, and you can basically program it in a way that you can receive multiple different type of data from the same cable. So, for example, you want to monitor strain or temperature changes, it can be, there is a possibility to do it within the same cable. All right, let's move to the next slide. Yeah, so this is basically a few methods of how we measure the light inside of the cable, basically, and different monitoring principles depending on the way we want to, and the parameters that we want to measure. So I don't want to go too much deeply into this kind of part because it's super technical. Maybe I will have our CTO Sergey to talk a little bit about this point, because this will be covered also later on down in the PPT. So here I would ask Sergey to join me and say a few words about Raman, Brilliant, scattering, and the way the signal works. Sergey?
Yes, are you listening me?
Yes.
Okay. So I think that right now, maybe it's not very important. In optical, we have three fundamental effects. This is Brillionovsky scattering, Raman anti-stocks and stocks signal, and the same fiber optics on the Bragg gratings. I think the better if Yuri will be continue. If we will have some, if needed, some explanation about fundamentals of these effects in fiber optics, then of course I can give more explanation. But after we go ends, I would like to show you some samples, real samples, with which we work right now. This is, I will explain a little bit later. Okay, Yuri, maybe it's better if you will be continue.
Okay. All right, let me continue then. So, Anshu, let's move to the next slide. Yes. Okay, let's jump to the next slide. Yeah, so as Sergey right now mentioned, there are different types of approach to fiber optic sensing, and obviously there's different type of technologies. But we can put it all into 5, or let's say, and then the other 2 would be an additional conventional MEMS technology, or microelectromechanical system technologies, and even analog technologies that we can use to supplement and even improve see from the fiber optics. So basically, three main types. One would be the distributed temperature sensing, or the DTS, the distributed strain sensing, or the DSS, and then fiber grating technology, which is a point-based fiber optic sensing technology. And then the number four would be the microelectrical mechanical systems, or MEMS, or and some analog sensors, conventional one, which probably a lot of people should know. Those would be just kind of various conventional sensors that everybody is using. All right, so let's move to the next slide. Okay, so this is basically how the system works. So we have the main unit, and then we send the optical signal within the fiber cable. We can also set up the resolution, like how at which distance, let's say, we want to have a measuring point, let's say every meter. And then we will receive the data. So if we have, let's say, a spectral resolution of 1 meter, and we have a cable length of 25 kilometers, for example, that means we have 25,000 sensors potentially within the single line of cable. That means we can get the data from 25,000 points across this entire cable. So this is just a simple way to understand one of the advantages that this technology has compared to traditional sensors, and the coverage that it can bring to any type of the infrastructure. Okay, let's move to the next slide. Okay, so besides the cable itself, as mentioned earlier, the fiber optics also has a lot of point-based sensors. So one of these types you can see on the picture on the right side, and then below the picture you can see the principle of how the things are measured inside of the cable, inside of the fiber optics. I think Sergey will cover it a little bit more in details later on. So let's just move to. Okay, this is the same.
Yuri, maybe you little bit return for one slide. Yes.
Okay.
I just want to explain. On that slide, you can see sample installation extensometer fiber optics on core, where is with that device we can measure convergence of tunnels. This is just a sample how it look like on a real condition. We have a hole on through beton hole through soil, then on cores, and when we install, we can see ground movement behind our concrete walls. Okay.
Okay. All right. Thank you. Let's move to the next slide. Okay. This is the principle also related to the Rayleigh, Brilliant, and Raman backscattering. So this is we'll cover later on. Let's move to the next slide. Okay. So yes. So basically, how does it work? Again, based on different principles, we can apply different principle to detect different kind of things. So either it's going to be distributed strain sensing or distributed temperature sensing. And for that, we use either Brilliant or Raman backscattering. Okay, let's go back. Next slide, please. Okay, these are some capabilities of distributed fiber optic sensing technology. So the range can vary from 10 to 100 kilometers based on the conditions and the technology that we use. The sample points can be also usually for the distributed sensing, we typically use the accuracy of 1 meter, but it can be increased or decreased in depending on the project requirements. Temperature range is also, as you can see, very wide. We do also have some abilities to cover even a higher temperature range than this one, but this is a typical one. Again, the resolution can be adjusted, and the spectral resolution also can be adjusted from 0.25 to 5 meters. That's a typical range. Okay, let's move to the next slide. Okay, so here we have yes, the same explanation. So this is the measuring time. So from 1 second to 1 hour, this also can be adjusted depending on the project requirements. Some projects which require very fast response rate, so we can get more data. Some projects which does not require that high measurement speed, that we can make it less time, but then this will also result in a much space saving, because a lot of data will be sent to the central machine, and if you want to store the data, that will lead to it will require a lot of space. Lower time will lead to obviously less space used on the hard drive. The strain resolution is one. They also can be adjusted, and the frequency as well can be different depending on the project requirements and the cable that is used. Let's move to the next slide. All right. Yeah. So these are just some benefits that we have when we use the fiber optics technology. So reliability, resilience, safety, cost effectiveness, efficiency, long range, and no false alarms. Okay, let's go to the next slide. So this is about the FBG, or fiber break grating technology. This is the point-based sensing technology, which is also widely used nowadays. That's basically, this technology have its own advantages and disadvantages. One of the, I would say, advantages would be that it's very precise at the point-based sensing, so we can decide where within the cable, like where would be the exact points where we're gonna install the sensors. So we can decide, for example, we can install the sensors every 5 meter, every 10 meter, and then what type of sensors can be installed on the same cable. So we can either use strain sensing, we can use temperature sensing. So this is a very highly customizable and very, very high sensitive technology, especially at the point based. So the difference between this technology and the distributed sensing is that it uses only a certain part of the cable as the sensing part. The rest of the cable is just serve as the communication channel to transmit the data. Okay, let's move to the next slide. Okay, so this is this is some kind of advantages that we have with this technology. So the main advantage is it provides absolute measurements that are independent of the fluctuations of the light in the optical cable. Low intention insertion noise, and also narrow band reflective spectrum with the FBG arrays can be easily installed along the single mode fiber cable. And then again, we have the ability to multiplex this technology. So if you have project that needs to be expanded, so it's very easy to add more sensors, more cables, even to the same main unit. So this can help us to grow the monitoring system across the entire infrastructure, like step by step, which is also very important, especially at the early stages of the project. Okay, so let's move to the next slide.
Wait, please return. I just want to give a small explanation. This is a picture. As you see, this is very shortly and sample how a system with FBG sensors can be used, for example, for calculate wheels numbers for train. The same if we install that cable with that system, we can check every time in real time quality. Is it good or not, or have some damage, some defects?
Yeah, like flat wheel detection or the number of wheels and axles. This is something that can be easily tracked with this technology.
Okay.
Okay, let's move to the next slide. Okay, this is just a few examples and a few pictures of how the FBG sensors might look like. A lot of strain sensors and different type of strain sensors you can see, and also temperature sensors and the main laser units or the modulators, how we call them. Also displacement sensors on the position 5, load sensor on the position 3. So these are just the way the fiber optic sensors looks like that are based on the FBG technology. Okay, let's move to the next slide. Okay, so again, like this is the application methods. So detection and localization of the geotechnical and weather induced structural failures, measuring surface temperature deformation and strain. So this is just the typical way we use the FBG sensors. Okay, let's go to the next slide. Okay, MEMS and conventional sensors. So these are the typical sensors that are used quite broadly, and it can supplement the fiber optics technology in a certain way. So among the conventional sensors, we might see some examples on the picture on the left side, but just to name a few, it includes some altimeters, weather stations, humidity sensors, also temperature sensors can be used as a conventional sensors, and then airflow monitors, piezoelectric sensors, MEMS accelerometers, and air quality monitors. So those are some examples. Of course, this list can be huge, but this is just a few examples of the typical conventional sensors that are used nowadays. Okay, let's move to the next slide. Okay, exactly. So this is the list continues. So extensometers, strain gauges and strain meters, crack meters, joint meters, load cells, pressure cells, settlement sensors, inclinometers, accelerometers, and data loggers. Those are all traditional type of MEMS-based sensors that are available also when we approach different projects. So now it's time to, before we move to the case studies, I think Sergey can say a few words about those principles that he was mentioning earlier, just to give the attendees some more insight on the principles of how the Rayleigh, Raman, and the backscattering, how it works. So I think, Anshul, if you can jump really quickly to the picture where we have seen the graphic. Okay, yeah, I think this one will work as well. Yeah, or this one. Both are fine. Okay, so Sergey, can you please give a little bit
Yes,
explanation about?
I can, but mainly for monitoring for sensing technology, usually use three different effects on optic fibers. On this drawing or picture, we can see two different beryllium scattering and Raman. If we look incident light, this is mostly look like responsibility which we have from fiber optics on Brega scattering. So
Okay, Anshul, yeah, keep that picture. Keep the other one with which looks similar to this one, the spectrum.
Okay, I didn't want to go too very deep. The main difference between all these is three cases that Brillion and Raman sensing systems. This system is not real time. So, because beryllium scattering, we have nothing inside fiber optics, only some internal defects. And when we push light, pulse inside the fiber optics, it takes quite long time and many times signal repeat before we can see that intensive that volume of reflected light will be changed. So for Brillion and Raman technology needed quite long time. Somewhere on a slide I see that it take up to 1 hour before we can receive a result. Advantage of that method that we must do nothing. We just buy traditional fiber optics telecommunication cable, put, and then use a special kind of interrogator with special kind software for analyze reflected volume signal and then make conclusion. Actually, when we work with Brillion and Raman reflected technology, we see the spectrum picture. Various different colors show different condition on parts. But as I told, this is not a real-time system. We must wait, we must collect a lot of signal, a lot of data, and all this system take a big amount of memory, of space for work with this is technology. In any case, this is quite wide use in oil industry, then the same railway for
अब उनकी बात आपको सुनाई देगी और आप भी उनकी बात सुनना।
In for that case, of course, the same is possible use for different kind of geotechnical application. That's why the main principle that peaks will be a change position and amplitude, and with software we can analyze what is happened and use, for example, time domain graph. We can see place because speed of light is almost constant, and of course we very easily can calculate place where is something happened with our object. Yuri.
All right. Okay. Thank you so much for the explanation. I think now
Excuse
let's
me.
just. Hello.
Can we go through some practical examples quickly because we are running short of time.
Yeah. Okay. So, Anshu, let's just quickly jump to the case studies, just to really briefly cover a few case studies, so that people can see also what kind of projects been accomplished. Um, Again, this technology is very highly adaptable. It can serve as to cover the most critical infrastructure, such as, for example, like highway rail monitoring. So you can see this is a case study number 1, for example, for seismic and structural monitoring for a highway railway in Bristol, UK. To develop and install, was the main objective, to develop and install a seismic and structural monitoring system for a newly constructed high-speed railway in an earthquake-prone zone. Okay, let's go down. So this was the objective. Just to quickly cover, so the speed of the train of 300 kilometers per hour, and the challenge was that the structural health of the tunnels and railway system needs to be in place. The science of the seismic activity and generating automatic alerts in the real time is required for this project. So this all was achieved by implementation of the fiber optics technology. So let's go to the next slide. I think that will show the results. Yeah, so here we can see we did install a different type of sensors at different locations across the project. And let's go to the next slide, so we just see the results page. Okay, so the results. So carrying out the real-time structural health and seismic monitoring, issuing automatic warnings as soon as one of the predicted thresholds is exceeded, including in the case of seismic activity, providing interactive surveillance, generating information for data-driven evaluation and decision-making, supporting a communication line between the national stakeholders responsible for a disaster response. So this is basically the few key results that the client wants to achieve. Let's go to the next slide. Okay, so this is for the immersed tunnel monitoring in Turkey. So the main objective was to develop and install a seismic and structural monitoring system for an immersed underwater tunnel. Let's go to the next slide. Yeah. So the challenges here stem from the need to develop a monitoring system that could monitor seismic activity as well as the dynamic load of the ever-changing but always heavy traffic inside the tunnel. Let's go to the next slide. The tunnel experienced a lot of temperature variations across the whole year, and that's why the temperature and strain monitoring was one of the key aspects of this project. So we did install a lot of point-based FBG sensors across the tunnel. Especially for the strain sensor, we use a lot of liner, displacement sensors to get the clear picture of what's happening when the temperature is changing, what's happening with the structure of the tunnel. Okay, let's go to the next slide. So this is the concrete spray tunnel monitoring. So also using a combination of the FBG and the conventional sensors to monitor the sprayed concrete lining tunnel. Let's go to the next slide. So in this project, we there was already some sensors installed, some conventional sensors, and we had like the challenge was basically to combine the data that is received from the conventional sensors along with the newly installed FBG sensors across the infrastructure, and then put it all together into one system to where we can see clear results and be able to analyze those different data that is received from totally different types of sensors in a real time and then come out with some results. Let's go to the next slide. Yes, let's just move to the next slide, to the results page, so that we can. Okay, so yeah. The result basically was that we found that the FBG sensors that are placed are in a good agreement with those that are more traditional sensors, and more importantly, when they combined with the FBG generated data, the previously unusable and rather patchy information from the pressure sensors would deliver the reliable and useful results. As a result, from the monitor and validated the original tunnel design, the planned additional tunnel construction would go ahead. So basically, we were able to combine the data that received from conventional sensors as well as the FBG sensors, and then put it in a very understandable format for the client, so that they can make the plans for the project expansion. Okay, let's move to the next one. The highway monitoring, for example, again, use different type of FBG sensors across the tunnel network to measure different strain. Okay, go to the next. Oh, Mr. Ashok, let's go to the next slide. So basically, 20 FBG sensors were placed in the test area of the tunnel while it's being constructed. Let's move to the next slide. So our system showed that basically when the heat, basically the structure of the tunnel behaves in a different way, especially during the different times of the day, when it's hot and when it's getting cooler at the nighttime. So this is all can be tracked, all the strain activity that is happening to the infrastructure with the FBG sensors. We can see the very clear curve of how the signal transforms, and then we are able to set up basically the we obtain the historical data, and then we can have the clear normal behavior in a digital format of the tunnel throughout the daytime, and then we're able to compare this data. If there is some problems required, this data will be compared to the historical data that is gathered within a certain time frame, and then any fluctuation to this data will be then shown as alerts to the operator. Let's move to the next slide. Yeah. So the results show that the carrying capacity of the test point on the cross section of the second concrete liner is primarily 10 initial stress, which then went on the transform into the pressure stress over time. The rate of the strain of the concrete on the outer edge of the second liner was higher than the one on the inner edge, and such changes indicate the complexity of the interaction between the wall rack and the liner structure. The strain values measured by the FBG sensors include temperature, stress, concrete shrinkage, and creep, as well as the various other kind of strain caused by the changes in the environmental factors that we can get using the FBG sensing technology within the tunnel. Okay, let's go to the next slide. Okay, this is basically a similar example to the previous one, although here we were mainly installing the DTS, or distributed temperature sensing based technology for the fire detection. Let's go to the next slide. Again, like the objective was to continuously monitor the temperature across the tunnel, to predict any possibilities of the fire events that can be acquired at any point. Our technology is also very well suitable to monitor any temperatures changes within the high voltage cables that are usually placed underground or in a special place within the infrastructure, and that's typically what can cause the fire if you don't monitor them properly. So these things been executed. Tunnel lining and track bed monitoring. So this is another project that's been executed. So we can see, so the client requirements was basically to track and monitor the tunnel network as one of the part of the metropolitan subway system. And the problem was that one of the piece of the wall was collapsed during this project and then lay on a track. And this has been basically detected by the monitoring system. Let's go to the next slide. Also we use a lot of conventional truth matter sensors here. Over 150 sensors were installed to monitor the deformation and the settlement of the tunnel. Let's go to the next slide. Yes, so this is some results that has been achieved. Basically, we were able to deliver high precision real-time measurements and a reliable wireless tunnel monitoring system that's been established. And it's not only that the wireless tilt meters were integrated into the old system that the client had, but also we were able to cover a lot of new blind spots that the previous old conventional system didn't have in this project, so that we were able to discover a few points which the client then needs to plan some schedule, some maintenance, and arrange some personnel. Okay, let's go to the next slide. Similar things here as well. So basically, we need to prevent the collapse of the tunnel. A lot of sensors have been placed as well. So let's go to the next slide. Yes, it's a highway tunnel. Let's go to the next slide. Yes, so basically, distributed fiber optic sensing were placed along the tunnel. Immediately generates a localized strain peak that has been detected. So this is something that we can showcase, where by integrating a new superior technology, we can immediately find out some spots that were not covered by the traditional sensors, basically. Again, like this is some principles of how the FBG sensing works. How does the cable looks like, and the sensors inside looks like, and then when the light travel inside of the cable, what kind of data?
Excuse me.
Yes.
Have you used this technology for longer bridges? Because we are more interested in the longer bridges also. We have more number of old bridges in Indian Railway than tunnels.
Yeah. Bridges, tunnels, buildings, all type of infrastructure can be covered. Because you see, the cable itself, like the fiber optic cable, it can be applied for any type of infrastructure, and the parameters that we are measuring is pretty much similar parameters. So it's we require to measure mainly it's measuring the strain, right? So then we can, based on this data, we can predict if there is anything happening at any point. And because it's a distributed sensing, so across the whole fiber, we can have a lot of monitoring points, which makes it very unique and very easy to install at any type of infrastructure. And we can pretty much cover the entire infrastructure and the critical points of it with just a single line of the cable. So no matter how big your infrastructure is, our sensors, like we can basically cover 25 kilometers with just one single cable line. And we have multiple channels, meaning we can install more than just one line of cable. So we are able to cover 25 kilometers one way, 25 kilometers another way. So and then if we use 4 channels, that you can multiply it by 4. So basically it comes 100 kilometers in total. So with this line of cable, you can cover your bridge, your tunnel, building, any type of infrastructure, and it can be done even for a quite a long range. So that's why this technology is widely used, especially within the tunnel network, because tunnel network can be very long. Same with the bridges. Bridges can be also have from a few hundred meters to a few kilometers long. This technology does not require any electricity to support it. And it can be applied in any kind of environment. So it does not afraid of water, any weather conditions, even some hazard environment. It can easily be installed. So this makes it much more better and superior compared to any other traditional sensors that are, you need to replace the battery, you need to supply the power. It's prompt to different electromagnetical signals, like lighting, for example, can cause damage to the sensors, and make them basically show wrong data, or don't show any data at all. Also, you need to think about how to transmit the data from the sensor over a long distance, for example. This is not the case with the fiber optics technology, because all the data is sent through the same cable. So there is a huge number of advantages when you use the fiber optics cables compared to the traditional sensors.
Do you have any case study for any long bridge, railroad, highway bridge, or railroad bridge?
We have, but I think they were not covered in this particular presentation, because this is mainly dedicated for the tunnel and subway monitoring. But we do have. We can send you later on case studies for the bridges that we have accomplished.
We can have question answer session. We can. I request participant to ask any question, any doubt, or anything.
Mm-hmm. Yes, sure. Just let me finish really quickly, just one more minute. Anshul, can we scroll down? Let's keep this few case studies. Let's just go down and go to the part where we kind of finalize the presentation. Okay, yeah, so just kind of a recap. So thanks to the innovative use of the state-of-art fiber optics technology, the MS Gecko is highly reliable. The system yield high accuracy measurements for a wide area of parameters and very efficient, so you can monitor thousands of locations using single fiber optic cable, and resilient. So MS Gecko is immune to electromagnetic, interference, explosion safe, cost effective, long range, so up to 60 kilometers with just a single line of cable, and it can also be extended using amplifiers to up to 300 kilometers. No false alarms. Okay, let's go down. Just to quickly mention a few words about the the parameters. So as mentioned earlier, settlement, corrosion, unusual structural deformation, joint movements, etc. Let's go down to the company introduction a little bit. Yes. Again, MS Systems is a subsidiary of Silex, which has been established in 1995. It's a global leader and manufacturer of the fiber optics equipment. The headquarters is located in the city of Kajaani in central Finland, with a production plant based in Bratislava. Let's go down. So we are specializing on solutions using the latest distributed fiber optic sensing and micro electromechanical systems, as well as the FBGO fiber break grating technology. Let's go down to the next slide. Next slide, please. This is just some basic advantages. MS Systems products and services are fully compatible with the highest industry standards. We are ISO certified as well. Now, the turnover of as you can see, we have operations in a lot of countries. The turnover of the company is also close to, it's basically over 25 million euros. Let's go down. These are just some certificates that have been achieved. Go down. All right, so now this concludes basically this presentation. Very well appreciate everyone to attend. We have a lot of people today, and I'm happy to answer.
Yeah, there are some questions on the chat. So could you please answer them as well, if you can see that? Yes, please.
Sure, I see them right now. So the first question is, can you sense stress without causing any damage of the structure? The answer is absolutely yes, because we does not damage the structure when we install any of our sensors. The number two, tunnel lining are supposed to be in compression while shall this crack. Again, any kind of infrastructure has its own aging, and you cannot also guarantee that there is no human error being made during the procedure. And our technology, we usually, when we set it up at the early stage of the infrastructure. So while the construction is still moving along, we are still able to multiplex the technology, so we can cover section by section while the construction is still happening. And this leads us to spot the errors on time, on the spot, and then let the client to fix the errors before they finalize the project. The third question is, in unreinforced tunnel lining, what is there to corrode?
Recording in progress.
the corrosion is not for the tunnel mainly; it's for the elements. And again, like this is not 100% must be monitored for all type of tunnel. This is just one of the possibilities that the technology is provide. And in case you need certain spots that has been prone to corrosion that needs to be monitored, some elements, those elements can be easily monitored using the fiber optics technology. How dynamic strain is different than strain? Okay. The dynamic strain is basically this is something that we measure in a real time. So then there is some strain that it does not need to be measured in a real time. It takes a lot of time to acquire, and some elements that require dynamic strain sensing. For that, we're mainly using the distributed fiber optic sensor with the high speed, with a response of 1 second, for example. This allows us to track all kinds of changes within the infrastructure in a dynamically. But some parts, especially related to the geotechnical parts, are not necessarily needs to be monitored in dynamic mode. So then we just allocate some certain time when we send the pulse along the cable, and let's say 1 time per hour, enough to monitor those kind of parts. Can you comment upon residual life based on the sense data? So again, like we are accumulating a lot of data over time, and this helps us to build a historical history of the structure, and then we can have some. When we analyze this data, we can see how the trend. So if there is certain spots of the infrastructure been, let's say, move into one direction and does not coming back to this original stance, then we are able to track it, and this helps us to really have the lifespan of the infrastructure in a put it on in a digital format in a very visual way. We can see how the infrastructure behaves at a different time of the day, at the different season of the year, for example. And then this also helps to plan the further maintenance works for the client. So unnecessarily maintenance is not required if the data shows that everything is fine. So it also helps to decrease the cost of the maintenance. While show there be ground displacement tunnels are supposed to be in a stable soil zone. Again, the displacement is one of the parameters that can be monitored. The ground movement is present around the tunnel, no matter where the tunnel is. This is something that cannot be avoided, and a lot of times our clients will ask for the ground movement monitor, and displacement can be applied to certain elements of the tunnel. If there is any cracks or something acquired, we can also monitor their life and how they propagate across the certain time period. In what form the results will be given, in strain form or in strength form, please? Okay, so we have a visual interface. When we supply the software, we usually give a digital format of the results as well as the graphical format of the results. But most of the systems are pre-set up once we deliver to the client. And then basically the client does not need to do any manipulation with the system on its own. It works fully automatically and is just sound and send notifications of the alarms of the different events that are requiring across the infrastructure. So normally we will provide some training also to the personnel, but it's pretty simple to understand, because we want to make sure that even the non-technical people are able to, when they receive the information from the sensors and it gets analyzed, we show the clear data and the clear results that are happening with the, at a certain spots of the infrastructure. So you don't need to do the analysis on your own. Basically, it's all done by the software. Okay, I hope I covered just really quickly these points. I don't know if Sergey wants to add something.
Yes, I want not add, but maybe a little bit discuss about other possibility and show some sample. Right now,
Okay.
for example, I will try, just a second, I must share my screen. Where is, that's for example, okay. I am not sure, are you see or not?
Yes.
This line, right now in Minsk, we work with one quite big project. This is subway, new line, third line. The total length about 15 kilometers. This is drawings, what documentation we ask from our customer when we work with different kind of project. From that
कंट्रोल नहीं होता था, चाह के भी कम करने में असमर्थ रहा मैं। तो उसी मिशन ने मुझे बताया कि मुझे किसी साइकियाट्रिस्ट की जरूरत है, तो उन्होंने मुझे भर्ती किया अस्पताल में। तो सिगरेट
sorry.
Yes, you can carry on, Sergey. Yeah.
Continue.
I will be very shortly, and this is not have any commercial secret, so it's not worried. I just show a real sample. We have lines, we have drawings. This is start a new construction, and then this is lines go. We have some station for metropolitan, for subway, and so. And practically that's project split for two stages. First stage when we work during construction period, and second stage start when all is ready. For the first step, we work about wall in the soil, meaning that when they do excavation for deep about 25-30 meters, they interested about pressure soil on the construction. For that we use different kind of technology, the mainly FBG, and we install on every point where is needed fiber optics, and then give information in central office in the Minsk. That's advantage our technology and when we can offer. Of course, for that we use, we work together with our customer. They pass us all construction drawings. For example, this is one subway station. We can see this is entrance 1, 2, then main lines with two direction metropolitan trains. And of course we have different kind of documentation which needed, and then have some discussion about which kind of technology they use for excavation, what is the problem they expect, and then we give complete solution what we can do and how it look like. Right now we have a very big project in St. Petersburg. This is Russia, about one new, very big, the biggest of the world will be some ice hockey stadium. The same. We start from 0 point and together with our customer install cables under basement for checking, for monitoring of deformation, settlement. This is basement. So of course we would like, we can offer our technology and work together with our Indian partners about all and give all our knowledge, all what we know. Okay, if you have question, of course we would like, we can give answer for different kind. Yuri.
Okay, thank you, Sergey, for sharing all this information. I think the probably the best way to understand how the system works and what we can offer really, and is to share with us some of your projects that you may have, or either past projects or new projects, and then we're able to come out with some kind of proposal as to what kind of things we can and we are able to do, and how we can help you guys to achieve the best out of the out of monitoring different stages of your projects.
We will share your presentation to our field units of Indian Railway. We are having so many construction units, so you can email your presentation to us and we will share. So any field unit having any problem, or if they are going for thinking of such thing, then they can contact you.
Right, sir. I'll surely.
Yeah, no worries.
Yeah.
Mathur,
All right.
Mr. Mathur,
Yes, sir.
I think it's time.
Right, sir. I hope you like the presentation and everybody.
I will request you kindly share your number and email also.
Right, sir. I will do it right away. I will do it right away.
Okay, Yuri, give me 1 second. I just show our friends some real-time data which comes right now. Please looking. This is we receive data through a cloud service which comes from Belarus. They have 160 meters mast which used for telecommunication, and we install our sensors and receive data. This is just sample which what information our customer can have. This is data comes to me, comes in some project institute, comes to customer, because this is very high construction and they have some special requirement. They must check how mast is geometry, vertical or movement. We can see that we can offer and work with our customer as he want. We have raw data, and then a representation can be different kind. What our client want. This is, we can see.
Yeah, I guess what Sergey is trying to say is that basically all these software things and the visualizing of the data is all customizable and can be done according to the client's requirements, the way the client wants to receive the data and visualize it. This is all can be achieved because we not only manufacturing all the technology in-house, but we also provide the software, and our software engineers can do all necessary modifications according to any specification and the client's requirements. It's highly customizable.
Right.
Oh,
All right. Thank you, everyone.
Thank you, Sergey, for the technical support. Okay, so Omkar sir, I hope you liked the presentation, and then we can take it further. You can share our number and the email ID that you have to anyone who wants to connect to us.
Okay, thank you.
I visit our foreign minister website and start read, but special attention, please. Not planning travel to India, South Africa, and so I am very sorry. And we, of course, all waiting when situation go normal way that we can come any moment to meet with you and spoke.
Right.
Thank you.
Thank you, sir. Thank you. So,
Good luck.
yeah, thank you, everyone, and good day.
Good day.
Thank you.
Yeah. Bye-bye.
Bye-bye.
Bye-bye.